Scaling Kafka to support PayPal's data growth by Monish Krupa. 100.3k claps. This must be good. Apache Kafka is an open-source distributed event streaming platform that is used for data streaming pipelines, integration, and ingestion at PayPal. It supports our most mission-critical applications and ingests trillions of messages per day into the platform, making it one of the most reliable platforms for handling the enormous volumes of data we process every day. To handle the tremendous growth of PayPal's streaming data since its introduction, Kafka needed to scale seamlessly while ensuring high availability, fault tolerance, and optimal performance. In this blog post, we will provide a high-level overview of Kafka and discuss the steps taken to achieve high performance at scale while managing operational overhead and our key learnings and takeaways. So far, sounds interesting. Kafka at PayPal. Kafka was introduced at PayPal in 2015 with a handful of isolated clusters. Since then, the scale of the platform has increased drastically, as PayPal's payment volume have grown significantly over the last 5 years. At PayPal, Kafka is used for first-party tracking, application health metrics, streaming, and aggregation. So we see both business logic wise metrics like first-party tracking and also application health metrics, also operational metrics. Streaming and aggregation, database synchronization, also database synchronization, so some system operations are going through it, application log aggregation, also the logs, everything is going through Kafka. Batch processing, risk detection, and management, and analytics and compliance, with each of these use cases processing over 100 billion messages per day. And I'm pretty sure this blog post also went through Kafka in the systems of Medium. Who knows? Everything is going to Kafka. Kafka is going to Kafka. Okay, so today our Kafka fleet consists of over 1,500 brokers that host over 20,000 topics. Wow. 1.5k brokers with 20,000 topics and close to 2,000 mirror maker nodes which are used to mirror the data among the clusters, offering 99.99% availability. So 99% is 3 days, 99.9 is 3 days divided by 10, basically. So it's around, I would say, 7-8 hours. And then 7-8 hours divided by, so this would be like something like 40 minutes, just a rough estimation, 99.99. Availability for our Kafka clusters. During the 2022 Retail Friday, Kafka traffic volume peaked about 1.3 trillion messages per day. At present, we have 85 plus Kafka clusters. Wow. And the number of clusters is more than 85. And every holiday season, we flex up our Kafka infrastructure to handle the traffic surge. The Kafka platform continues to seamlessly scale to support this traffic growth without any impact on our business. How in hell is that working? So we see here the number of messages, 15 million. Yeah, and there are some peaks around November. Incoming messages per second, so 15 million messages per second with peaks of 20 million messages per second over the holiday season. Retail Friday 21 million per second. Cyber Monday 19 million per second. Yay. And per day it was 1.32 trillion and 1.223 trillion. By the way, I would ask myself whether all these messages are actually needed. I mean, sometimes you need to do cleanup, just like you clean up your hard drive. Sometimes you need to check which messages are flowing and whether you really need them, or some cleanup processes, technical debt. So, operating Kafka at PayPal. PayPal infrastructure is spread across multiple geographically distributed data centers and security zones. The Kafka clusters are deployed across 3 zones. Based on data classification and business requirements, Mirror Maker is used to mirror the data. So this sounds like an interesting tool, this Mirror Maker, which is mirroring the data across the data centers, which helps with disaster recovery and to achieve inter-security zone communication. So here we see data center 1, data center 2, data center 3, and they have the data mirroring in between the Apache Kafka cluster. Right, it's mirroring across the data centers, and all the client apps would see the data, including the data that needs to be mirrored because it's cross data center. And here what we see a couple of Kafka clusters. We have the mirror makers, again in between some Kafka cluster, not all of them, because the mirror maker is between the different zones, right? So they have it in between these, but it wasn't specified if we have one also here. Kafka cluster deployment security zone within data center. Availability zones. Yeah, because this is across a single data center. So it's the mirror maker is also used in between the availability zones, which are inside a single data center. Each Kafka cluster consists of brokers and zookeepers. Client applications connect to the topics hosted on these brokers to publish or subscribe the data from 2 clusters on the same or different security zones via Mirror Maker. At PayPal, we support a wide array of clients such as they have both Java, Python, Spark, Node, and PayPal internal frameworks, and Golang, and more languages even. So here, we see even more data. We have some Kafka control plane. We have here the brokers, the actual Kafka clusters. We have some PayPal Kafka client library. And we have the data store of the metadata, Kafka config service. Okay, so we see a couple of applications here. Control plane frontend, control plane backend, some Kafka cool and automation, Kafka monitoring, Kafka security, live patching plugin. So it includes both deploy. This looks like a deployment and of the Kafka cluster and all that is around it. Kafka libraries and components. Operating Kafka at PayPal comes with its own set of challenges with multiple different frameworks, tech stacks, legacy applications, and internal external products we interact with. We need to keep evolving and investing in building robust tools, which helps us reduce and manage the operational overhead. Over the years, we have invested in a few key areas that have helped us to manage our ever-growing fleet of Kafka clusters, to have simple client integration, better dependency management and consistency, release new features and enhancements for security and platform stability. Some of the areas that we have invested include cluster management, monitoring and alerting, configuration management, enhancement and automation. Cluster management. To have better control over Kafka clusters and reduce operational overhead, we have introduced a few improvements, including Kafka config service, ACLs, PayPal Kafka libraries, and Q environment. And now they begin to explore the environments that they introduced, the improvements. So the first one is the Kafka config service. Before Kafka config service came into existence, clients would hardcode the broker IPs to which they connect to. In case of any maintenance activity, we might need to replace the brokers due to various reasons such as upgrades, patching, disk failures, etc. In this scenario, it caused a maintenance nightmare with multiple incidents for us to handle. Another issue is the lack of understanding with multiple configurations Kafka provides and what it does, due to which the Kafka clients would override these properties. So basically it's the configuration of the clients without the know-how on the implications of the same. This resulted with a lot of noise and impacted, just imagine you have so many clients that you need to manage. Engineering bandwidth in terms of product support. The Kafka config service is one of the most critical, highly available stateless services. Interesting. So here we have some configuration service, right? We see we have some configuration service, and this configuration service is said to be stateless, is highly available, and is critical also. It is implemented to reduce considerable operational overhead of the site reliability engineering, ASRE, and the application teams. Kafka clients need a set of bootstrap servers. During initialization, which are the set of brokers on which the topics are hosted, and application connects to the same brokers producing, consuming the messages. So we see the concept of initialization and bootstrap services. This service pushes the standard configuration. Interesting to know whether this is an actual push, meaning they are constantly connected to this service, and it's like a polling or SSE, server-side events, where you push the configuration to the clients or WebSocket clients using Kafka. So the configuration is pushes the standard configuration to all the clients using Kafka. Kafka itself is pushing, along with providing the necessary bootstrap server details. All at the start of the application, important. Application starts, fetch the configuration. In case of any issues, the application team do not have to rely and spend time on follow-ups with the platform team, but can simply restart their application to incorporate recent changes. Unless the problem is permanent, right? Benefits. Offer plug-and-play model for Kafka clients, reduces operational support overhead, helps in standardization of Kafka configuration across multiple different clients. Okay, so let's see this. So here we see client applications are connecting with read and write to the Kafka clusters. And here we need to bring some Kafka properties from the configuration service, right? We need to know that we have T1, T3, and so we read. And here we have the Kafka metadata. The thing that was not clear is how is Kafka used to bring the configuration if the configuration itself is saying which Kafka to use. Hopefully they will describe this. Kafka clients retrieving bootstrap servers configuration from Kafka configuration service, or maybe they just called it Kafka configuration service, so it's just standard configuration service and not Kafka provided configuration. Kafka ACLs. Before access control lists came into the picture, Kafka allowed connections on plain text. I see this repeating in multiple blog posts where they start by connecting to Kafka without any authentication, and only after some time they add the authentication. Kafka allowed connections on plain text port, and any PayPal application could connect any of the existing topics, which was an operational risk for our platform, which streams business critical data. ACLs were introduced at PayPal to ensure controlled access to Kafka clusters and make our platform secured by enabling access only via SSL port. This requires applications to authenticate and authorize in order to gain access to the Kafka cluster and topics. Each application needs to explicitly call out if this is a producer or consumer, or for the topic it wants to connect to. We have incorporated these security changes in our client library. Benefits. A highly available and secure platform offering low latency for our business critical workflows, record of every application accessing topics and clusters and their intent. We have implemented ACLs across all of the Kafka clusters using a unique application context assigned to every PayPal application. For identification, you need to identify which app in order to know which ACL. This has reduced maintenance effort dramatically. PayPal Kafka libraries. At PayPal, we need to ensure our clusters and clients connecting to them operate in a highly secure environment. Additionally, we need to ensure easy integration for multiple frameworks and services within PayPal to provide a seamless experience to our end users with reduced time to onboard and enhanced focus on developer efficiency. To do this, we have introduced our own set of libraries, of which the major ones and their importance are highlighted below. Resilient Client Library. The Resilient Client Library integrates with our discovery service without developers needing to know the implementation or configuration details. Once the client tries to establish connectivity to the cluster, this library will fetch the information on Kafka brokers. So need to know who are the Kafka brokers. It would fetch this information, the default or overriding configuration for producer or consumer, application startup, and more. Benefits. Topic portability when the Kafka cluster are clusters as well as different environments. As we said, every problem can be solved by another layer of abstraction, reduces the impact to business with operational changes, developer efficiency. Monitoring library. The monitoring library publishes critical metrics. I'm going over this quickly because this is standard for client applications, which helps us to monitor the health of the end user applications. We use Micrometer, interesting to see this library, to publish these metrics, which allows us to change the metrics and the way we monitor our application. Benefits. Application can set alerts and be notified in case of issues, help us to monitor and keep Kafka platform stable. Action on any issues within a few minutes of turnaround time. Kafka Security Library. All the applications should be SSL, Secure Socket Layer. Authenticated to connect to the Kafka clusters, this library pulls the required certificates and tokens to authenticate the applications during the startup. Benefits. So they have a couple of libraries, one library for monitoring, one library for ACLs, one library for SSL. Benefits. Kafka platform at PayPal supports more than 800. Note that they have libraries and not agents or processes. PayPal supports more than 800 applications. This library avoids the overhead for the end users with respect to key management. This means that every time you change the library and you want everyone to update, all the applications need to update, which is okay. This library avoids the overhead for the end users with respect to key management events such as certificate updates, key rotation, etc. Required minimal know-how on authentication authorization when connecting to Kafka clusters. This is probably the number of support tech stack for Kafka. Now imagine that all these libraries need to be written in all these languages: Java, Python, JavaScript, Golang, whatever other frameworks they have. PayPal Raptor framework. Kafka QA platform. As Kafka evolved, we observed the need for a stable, highly available production-like QA platform for our developers to confidently test their changes and go live. The older environment was cluttered with a lot of ad hoc topics, all hosted on a handful of clusters and with feature disparity compared to the production setup. Developers would create random topics for their testing, which would cause issues. So this is a good question. Do you want in your QA or developer testing actual Kafka with topics? Let's see what they said. They said that they had originally actual Kafka topics, then they got cluttered because people just created a topic for testing, and now let's see what are they doing, which could cause issues while rolling out the changes to production, as the configuration on the cluster topic details would be different from the one used for testing. We redesigned and introduced a new QA platform for Kafka users to resolve the above mentioned issues. The new QA platform provides one-to-one mapping between production and QA. Okay, this makes sense. So when you create a topic, you will have one in QA and same one in production. And now so first, they do use topics in QA. Yeah, right? They didn't say we are going to ignore that we have topics and only unit test or whatever. Second, they have one-to-one mapping. You created a topic there, you will have it here. You create it in production, you will have it in QA, or you create them in parallel, but there is a one-to-one mapping. Looks good. Following the same security standards as production setup. We have hosted, make production as similar as possible to QA, as similar as possible to dev, similar as possible to laptop, as much as you can. As much as makes sense as you can. We have hosted all the QA clusters and topics in Google Cloud Platform with the brokers spread across multiple zones. Within GCP, with rack-aware features to achieve highly available, along with a rigorous evaluation for finding the right SKU without compromising performance. We optimize the public cloud costs compared to the older platform. Our new platform reduces the cloud cost by 75% and improves the performance by about 40% benefits. Reduce time to roll out changes from QA to production, one-to-one mapping with production clusters, cloud optimized solution. I really like this one-to-one mapping. So you don't need to think too much. The same topics would be there. You don't create magic topics in dev just for testing. It's going to be the same ones. Interesting. Monitoring and alerting. One of the challenges with operating at scale is how efficiently we monitor our platform, detect any issues, and generate the alerts to action upon them. The Kafka platform is heavily integrated into the monitoring and alerting systems of PayPal. Apache Kafka provides tons of metrics out of the box, but we have fine-tuned a subset of metrics that help us identify issues faster with lesser overhead. Each of our brokers, zookeepers, mirror makers, and clients sends these key metrics regarding the health of the application as well as the underlying machine. Each of these metrics has an associated alert that gets triggered whenever abnormal thresholds are met. We also have clear standards operation procedures for every triggered alert, which makes it easier for the SRE team to resolve the issue. This plays a major part in operation, platform, and scale. We also have our own Kafka metrics library which filters out the metrics. These metrics are registered in Micrometer. I'm going through this quickly. Registered and are sent to SignalFx backend via SignalFx agent. SignalFx agent runs on all, I'm not aware of SignalFx. What is it? If anyone knows, let me know. Runs on all the brokers, zookeepers, mirror makers, and Kafka clients. Notable open source contributions. We have open source contributed blah blah blah. Keep 351 help increase the visibility of under min sync replicas. Keep is Kafka problem improvement. 497 help monitor the clusters that had any at min in sync replicas. At min in sync, so they're in sync, but it's at minimum replicas. Help monitor, mainly monitoring the user polling behavior for consumer application. Configuration management. This is configuration management helps us to have complete information on our infrastructure. In case of loss of data, this is our single source of truth, which helps us to rebuild the clusters in a couple of hours. Entire Kafka infra metadata, such as details on topics, clusters, application, etc., are stored in our internal configuration management system. The metadata stored is backed up frequently to ensure we have the most recent data. Benefits. Serves as a source of truth in case of conflicts, recreating clusters topics in case of recovery. Enhancement and automation. As with any large-scale system, we have built the tools to quickly carry out operational tasks. We have automated CRUD operations for clusters and topics, metadata management, patching our infra and deployed changes. Some of them are highlighted in below for further details. Patching security. We use bare metal for deploying the Kafka brokers with virtual machines for zookeeper and mirror makers in our environment. All hosts within the Kafka platform need to be patched at frequent intervals. The Kafka topics are configured with a replica set of 3. Security enhancements. Apache Kafka prior to version 2.6.0 only supported loading certificates by reading. Okay, they had a keep. Operational automation. Listed below are the key automations in place which helps us to manage our operations on a day-to-day basis. Topic onboarding. Application teams are required to submit a request to onboard a new topic via the onboarding dashboard. So when you have a new topic, you need to request it. The capacity required for the new topic are reviewed. So it's like a ticket maybe. Reviewed by the team and onboarded to one of the available clusters. The availability of the cluster is determined using our capacity analysis tool, which is interesting process for onboarding new topics. Is integrated into the onboarding workflows. For each application being onboarded to the Kafka system for the first time, a unique token is generated and assigned. This token is used to authenticate the client's access to the Kafka topic, followed by creating ACLs. So you create a topic, you need to have a token, they will generate for you the token via the onboarding process, followed by creating ACLs for the specified application and topic based on their roles. Now the application can successfully connect to the Kafka topic. So we see here the process. We have a Kafka user, he requests a topic. So he has some UI where he asks for topic. The Kafka team, let's say they accept it, they review it, they find out the cluster. But now they need to create a topic ACL, and they also need to create the ticket, the token. Mirror Maker onboarding. We have mirror makers to mirror the data from sources, cluster, and another case of onboarding cluster to destination cluster for specific use cases where the producer or consumer application is running in different zones. In such cases, we set up mirror makers by following the processes shown in the below diagrams. Okay, so we onboard also to Mirror Maker. Also here, so it's not enough that you created that Kafka topic, you need to ask to onboard to the Mirror Maker with the Kafka onboarding UI. The Kafka team will review and accept the request. Then, ServiceNow. So they will update the request. The ServiceNow is for some workflows. Someone will approve it from security. And you will get back the approval on ServiceNow for the mirror. Repartition assignment enhancement. Okay, this goes on and on. I'm not sure. Partition reassignment is the process of redistributing or reassigning the partitions of a topic among the available brokers or nodes in a Kafka cluster. This is required when we flex up the Kafka brokers, carry out any maintenance activity on a subset of brokers, or while replacing the brokers. By default, Kafka does not repartition for all the partitions, including the partitions which are hosted on healthy brokers, but we have made modifications to reassign only under-replicated partitions hosted on the affected brokers. This enhancement helps avoid unpredictability, longer task partitioning. Key learnings. Okay. Operating Kafka on a large scale requires tooling, like the onboarding tools they have, which helps with regular operations such as cluster installation, topic administration, patching security vulnerabilities, etc. We are continuously working on building and improving our existing automation and tools to reduce the operational overhead. Yeah, we have seen here a huge amount of tools. Alerting and monitoring important health metrics are extremely critical for the infrastructure to be highly available and to avoid any impact on the business. Along with monitoring the metrics such as bytes in, bytes out, CPU utilization, disk utilization, etc., we need to constantly work towards the fine-tuning our metrics to ensure we receive actionable alerts. Initially, due to limited engineering capacity, our focus was to build tools to onboard multiple applications and use cases to the Kafka platform. Over time, this resulted in us losing track of the applications, which severely impacted us while carrying out maintenance activity. We introduced ACLs in order to have better know-how on the applications connecting to our platform and at the same time add to improving the security of our platform. To avoid managing ACLs becoming an overhead, we are working towards building tools which can automate the manual effort. Benchmarking the cluster performance on multiple environments, on-prem, public, cloud with different configurations, help us to gain insight to achieve operational efficiency, both in terms of performance and cost. Conclusion. The Kafka platform at PayPal, since its inception, has always sought to provide its end users with a seamless way to integrate and stream the data with the least amount of friction and the highest availability. We strive to build the necessary tools to ensure our platform seamlessly scales to handle increasing the data traffic. As we do this, we learn every day, discovering innovating ways to enhance our platform and improve the availability, the ability to provide an amazing user experience. I hope this was interesting read and would love to hear any thoughts or feedback. Yeah, I think this was very interesting. Looks like we need to take each and every component and understand better how it's working, but it looks like there was a huge amount of work here. And this I think brings the visibility that with handling 20,000 Kafka topics, 1,500 machines with 99.99% availability, you need all these tools. You need all these both onboarding tools. We need all these health additions, open source contributions. Acknowledgement, the success of the Kafka platform at PayPal has been massive team effort. Yeah. A lot of people have contributed over the years to help to make the Kafka platform at PayPal become highly available and standard. We'd like to thank Krishna, Siram, Apurva, Katrik, Manoj, Pesav, Aditya. Oh my God, so many people. Okay, yeah, so this deserves indeed. So this was scaling Kafka to support PayPal's data growth, and we are going to follow this guy.